John Robinson, principal scientist. Hello, John. And John is going to talk about, I think, a higher level view of the MicroLED process, looking at, yields and the complete process control, something that KLA can provide. And so hello again, John, and you've got the floor.
Okay, you can hear me okay?
Yeah, I hear you perfectly.
Okay.
Yeah.
Thank you for the honor to do this discussion today. Really appreciate this opportunity. I'm at a hotel with questionable internet, so we'll just have to hope for the best here. All right, so I'm not going to do absolutely end-to-end process control, so that slightly exaggerates what I'm going to talk about today, but I will certainly discuss as much as I can. So first, a little bit about KLA. Most people who know about KLA from the semiconductor end of the equation. So, the substrates, the reticles, the chips, this kind of thing. What many people may not know is we've done a number of really excellent acquisitions in recent years for packaging, for components inspection, for printed circuit board, PCB, flat panel display, and process tools as well. So we have a very broad portfolio of capabilities across the spectrum, and that is very relevant for the MicroLED discussion. So two of the companies I want to talk about today are based on recent acquisitions. So my agenda is a little bit like this: introduction, brief discussion of end-to-end process control. If people want to hear more, I can certainly have some other discussions offline as well. And then two case studies, one on release etch processing of micro-LEDs, the other one on mass transfer placement metrology of micro-LEDs. And then finally, some concluding remarks. Okay, so micro-LED display, I think everyone knows, has some compelling opportunity. LCD is currently the low-cost, largest market share display available today. OLEDs are slightly more expensive, but a lot less expensive than micro-LED, and offer a number of technical advantages over the LCD. But I think what many of us are here for is the going even beyond that to micro-LED. They have a number of technical opportunities, advantages, potential advantages over the existing incumbents, including brightness, fast refresh, high pixel density, high efficacy, low power consumption, things of this nature, which is great. And I think for some of us, even beyond sort of conventional display metrics, there's also the sort of more than display opportunity, right? There's a lot of empty real estate between the LEDs and the size of the pixel. So there's opportunity to either make the display transparent or very good blacks, or more compelling, I think, is to put other types of sensors and devices than we're used to today to make a screen much more interactive than we're used to in ways that we probably can't even really think of yet. Of course, the downside, and we all know this, is the cost and manufacturability are key challenges right now. It's basically very, very challenging to appeal to the broad market with the current cost and manufacturability. So today I'm going to talk exclusively about the mass transfer side of the micro-LED, not the monolithic, as the previous was discussed previously. So there's a number of challenges. Extremely high quantity of pixels. Think of an 8K TV with red, green, and blue. That could be in excess of 100 million devices. Multiple device types. You have red, green, blue micro-LEDs. You have drivers depending on your integration. You might have sensors depending on your integration. So it's heterogeneous. These things are extremely small, tens of microns or even a few microns in size. It has to be low cost, something like 10 to the minus $5 per LED to really make this work. The mass transfer has to be extremely fast, something like 100 million devices per hour. Extremely accurate, sort of micron level accuracy or submicron accuracy, and it has to be very high yield, one way or another, to compete with the existing technologies that are out there. So very challenging. Show a little process engineer in the middle getting crunched by all the requirements that need to be met. So first, I'll talk a little bit about end-to-end process control. So first, just a high-level overview of the process. We have